Okay, so we're going over lesson 1 for the acids, bases, and solutions unit. So the first thing is what a solution is. And we've been making solutions basically the entire year. So a solution is a homogeneous mixture, which just means it kind of looks the same throughout. Okay, so a solution is made up of a solute and a solvent. So this would be like the solvent, okay? The solvent would be just whatever it is that's being dissolved, okay? And then the solvent, okay, the solvent is whatever is being dissolved in. So if you were to pour this in here, then it would be considered the solute and the solvent, which we've kind of done many, many times in labs. We just haven't gone over the vocabulary of it. Okay, so water is called the universal solvent, and that's because it's very, very polar. It's able to dissolve many things. So if you look at the molecule here, if you remember, water is made of oxygen and 2 hydrogens, okay? And if you remember at the beginning of the year when we talked about polarity, it's basically an uneven sharing of electrons. So the oxygen here will pull, it's very electronegative compared to hydrogen, so it'll be pulling electrons towards itself. So looking at the molecule overall, this part right here will be more negative than this part. Don't worry about the numbers. You won't need it in 10th grade. But just the general picture of this being an uneven share of electrons is what I wanted to illustrate to you. Okay, so solution. So remember, an aqueous solution is where the water is the solvent. So maybe not an alcohol as a solvent, but this would be like if this was water, which it is. So if I were to pour this in here, then it would be an aqueous solution. Let's pretend this is salt. It's not, but pretend it is. And if I poured it in here, it would be considered an aqueous solution. This was actually an aqueous solution, both of them. This is copper sulfate, which is an ionic compound, and this is NaCl, which is what you see on your screen right now. So for solubility, you can have saturated, unsaturated, and supersaturated. So saturated would be if you were to add sugar to water in the amount where the sugar still dissolves completely and you don't see any settle at the bottom. But if you were to add a little bit more, it would start to settle at the bottom when it's too concentrated. Unsaturated means that you can still add more. So if you add sugar to water and then you're able to add more with it dissolving, it was unsaturated, okay? And then supersaturated is how we make crystals. So basically, you will put some salt into here. This was copper sulfate, add it to water, and it was just a clear blue liquid all the way through. I didn't have this solid here. And this is actually the beginning process of crystallization. So basically, we added a lot of this stuff, copper sulfate, and it kind of settled at the bottom. And then we heat it up on the heating plate. And it became just clear liquid. It didn't have any of these crystals inside. It just was clear liquid, kind of like that. But then, once we heated up, it was clear, and then it slowly started to cool. Once it starts to cool, you get these really cool looking crystals that kind of just have their own shape. And the shape is different depending on what chemical is dissolved in it. And then some chemicals will actually dissolve much more readily than others. So for example, this one, we actually put, I think it was 3 or 4 times the amount of salt in there than in here. This is actually table salt, and it wouldn't even dissolve all the way. Even though it wasn't, it was super saturated and we heated up for a very long time and it never did dissolve. But it is super saturated still. It is forming crystals here, just not near as much as this example is. So like we've seen already, factors that affect solubility. We just talked about it, temperature. If you heat up the solution, you're able to fit in more solute. But gases have the opposite effect of that. We're just talking about like a solid substance, but if you have gas, actually if you heat up the temperature, it doesn't dissolve as readily. Now with pressure, we're only talking about pressure with gas, and if you increase the pressure, then your solubility of the gas will increase as well. Okay, so solubility curves. So you have a solid solubility curve for solids and a solubility curve for gas. So as the temperature rises, okay, you see that the solubility actually decreases. Whereas in the solids, as the temperature rises, most solids, the solubility will increase. So if you want, you can research why this chemical right here actually goes lower during solubility or when you heat up the temperature. We kind of touch on it in our our next unit. But basically it has to do with the heat of solution and what type of reaction it is, and Le Chatelier's principle. If you wanted to know why, we will talk about it next unit, or we can talk about it in class, or you can Google it, whatever. But just in general, most solids will become more soluble as the temperature increases. All right, so rate of dissolving. So how fast a solute dissolves in a solvent. So sometimes a solute will dissolve really quickly, like in this case where I was dissolving the copper sulfate. And then there's some cases where it takes forever for it to dissolve, where we heated this salt water solution up. This is just table salt. And it just never dissolved. It was not hot enough. Salt is not very soluble compared to this chemical. So it's not to be confused with how much, just how fast it dissolved. The copper sulfate, the blue stuff, dissolved really, really quickly compared to the salt, the NaCl. All right, so you can increase the dissolving rate, okay, by, of course, increasing temperature, and then obviously stirring it will help increase the rate that it'll dissolve, and then powdering. So this year we did a chemical reaction where we reacted copper sulfate with iron. So the very first year I did this, I used these pellets right here, and it just like the reaction didn't even happen. And it was kind of frustrating because the kids like stirred and increased the temperature and just nothing was happening. And I was kind of frustrated too as a teacher. You want something cool to happen for your students. And it didn't work. So then, after the next block, I went down to these, which are still slightly bigger or smaller than these, but still a little too big to dissolve quickly. So these little pellets didn't cut it either. The students were a little frustrated still. It was taking a long time, but we did see some results. Now, number 3 says powdering. So here is what we ultimately use, and this is what you guys use this year. It's just powder, or as powder as you can get with iron. And basically when you powder something, the surface area is so tiny, whereas here you have these things, and the copper sulfate can only have access to the outside of this, and there's so much more product inside. Whereas here, almost all of the product is available to the copper sulfate immediately, so the reactions occur much more readily. All right, liquid to liquid solutions, there's a couple of vocabulary words for this, and they behave a little differently. So with liquid solutions, you're looking at polarity and whether or not the polarity is what affects whether or not it will dissolve. So miscible is just the word we use for liquids when we talk about whether or not they will mix uniformly. So for example, if you pour milk and water together, it's totally mixed. You don't see two different layers. Now, if you mix two liquids and they form two phases or two layers, like oil and water is a classic example, it's immiscible. You see two phases, or you see two or more phases where obviously one is different than the other. And so that happens because of the polarity, okay? So basically, like will dissolve like. So if you have two oils, two nonpolar, molecules, it'll be miscible. They will dissolve with each other. If you have water and something else that is that is polar, that will dissolve, that's considered miscible. But if you have like something like oil mixing with something like water or alcohol, then it'll be immiscible, where it doesn't mix. So those are the two vocabulary words for whether or not liquids will dissolve within each other. Now, concentration. The two vocabulary words you kind of need to know is dilute and concentrated, which most of you use in your day-to-day vocabulary. Dilute just means it's a small amount of solute compared to a large amount of solute, which would be considered concentrated, and I think you all should know those two words.